Integral calculus, anti-differentiation. We're really at the start of integral calculus now. Turning differentiation on its head. This is really integral calculus, that's what I say it is. There we have the derivative, y equals x cubed means the derivative is equal to 3x squared. Now going the opposite way means we want to get from 3x squared to x cubed. Here's the notation that says integral of 3x squared. The dx means with respect to, and the same as here. Dy by dx means derivative of y with respect to x. This says the integral of 3x squared with respect to x. And because we're just reversing the process, we should be able to see that this is just x cubed. Meaning, derivative x cubed goes to 3x squared, integral 3x squared goes to x cubed. So we've reversed the process. There is, however, a very big but. Here are three functions which have the same derivative, and yet they're not the same functions. What is the essential difference between these three functions? It's this constant. Now remember that the derivative of constant is 0, so the constant's going to go. So whatever constant is combined with x cubed, I'm going to end up with 3x squared as a derivative. When we integrate to get the integral, then we need to make allowance for that. So what we do is we put a plus c on the end. Now that might seem to be a bit strange. It might say to you, well, you'll never really know the value of the integral then, but the way we use the integral, usually the c eliminates anyway. But we'll see about that later when we get to what's called definite integration, the definite integral. But at this stage, therefore, we have integral 3x squared dx is x cubed plus c. Let's test that. There's a formula now. Integral ax to the n dx equals, now remember when we differentiated, we subtracted 1, which means we add 1, and we multiplied by the n, so we divide by the n plus 1. So we're doing the opposite. Subtract goes to add, multiply goes to divide. So let's test it. I've taken that, there it is there, and I've differentiated it. So n plus 1 multiplies down, it cancels with n plus 1 below. We subtract 1 off n plus 1, and we get n. And of course c, when we differentiate c, we get 0. So there we are. Derivative of this gives you ax to the n. So integral of this gives you that, going the other way. Couple of examples. Here we are. We're going to apply that straight into the formula, but don't forget your c. Same thing here. Now, a basic assumption you can make here is the fact that the integral of a sum or difference is the same as the sum or difference of the integrals. So if we have integral of f of x plus g of x dx, we can write that as integral of f of x plus integral of g of x, each dx. We've done that already in the differentiation as well. So 2x cubed becomes 2x to the 4 over 4, 5x to the 1 plus 1, 5x squared over 2, and of course 1 goes to x. What was differentiated get 1 is x, or that's 1x to the 0, add 1 to the 0, we get x to the 1 divided by 1, x plus the c. And we've just cancelled down there just to simplify slightly. This next one. Now this is the same as when we started the calculus differentiation. You cannot integrate like that at this stage. In calculus, in differential calculus, if you are differentiating that, you could use the quotient rule. But originally, remember, we had to write each of them over the x squared. Now, that's the way we're going to have to go with integral. And one further thing, we cannot integrate 2 over x squared. We must write it as 2x to the minus 2. Now we can go for it. But remember, when we add 1 to minus 2, we get minus 1. So there we are. X to the 1 becomes x squared over 2. 4 becomes 4x. And of course, minus 1 dividing by minus 1. There you are. And we cannot leave it like that. You should always leave with positive exponents. So negative, negative, that gives you a positive, and you'll have the x going below. Some examples for you to try. In the first one, we just apply the formula straight off. Add 1, you get 5 over 5, and the 5's cancel. We get a 4 below. 6 over 4 is 3 over 2 plus c. Next one, straightforward, applying the formula. This one we're going to have to write that as x to the half and x to the 1/3 in order to be able to do it. And now we're going to say half plus 1 is 1.5 or 3 over 2, and we divide by the 3 over 2. 1/3 plus 1 is 1 1/3 or 4 over 3, so we have to divide by 4/3 plus c. Now when you divide by 3 over 2, it means you multiply by 2 over 3. When you divide by 4 over 3, it means you multiply by 3 over 4 plus c. This one we write each over the 2x squared, and the 2x squared below, the x squared below becomes x to the minus 2 above. Add 1, 3 over 6. There's already a 2 there, so if we're going to divide by 3, it must multiply with a 2. It becomes 4x. That becomes negative 1, and so it's 2 times negative 1, which is negative 2, and I've transferred the negative to there, so it's a negative instead of a positive there. And of course we cannot leave it like that, so we write the x below. This one we cannot integrate like that. We have to multiply it out first at this stage. So therefore I've multiplied it out, and now we integrate in the usual way. This becomes 12x squared over 2, which becomes 6x squared, plus 9x plus c.